So suppose you have the sequence and you do all of these differences, and the first time through you don't notice any patterns. You try dividing the second term by the first, the third by the second. You don't see any common ratio, and then there's just no pattern, recognizable pattern. You do the differences again and notice that there is a recognizable pattern. It's actually exponential. You can see that 72 divided by 24 is the same as 216 divided by 72. And once you see that, you know that it's exponential. So you have to know to try that. And then you think about, well, how would I generate these terms? And because 3 is the common ratio, that means that 3 is the base. Right, and then, okay, what times 3 is 24? That means it's 8 times 3, and then multiply that by 3, and that by 3, etc. So the idea is that you can now generate these terms here because you have a formula for these terms right here. So, for example, if I want to end up with this 314, I can start with the 2 and add 24 and 72 and 216. And I have formulas for those. So I would start with the 2 and add the 24 and add the 72, etc. And notice that I'm adding the number of terms here is one fewer than the term that I get right here. So I'm going up to 8 times 3 to the k minus 1. So again, I start with the 2, I add 24, 72, 216 until I get there, start with the 2, add all of these until I get to the term that I want. Okay, so this sum ends up being the kth term of this sequence right here. And of course, once you have a formula for that, you play the same game to generate this sequence, because now you have a formula for this sequence. See the next clip.